Hey, James. Can you hear me?
Hey.
Hello? Hey, how you doing, man?
Good. How about you?
Pretty good. I just had a chance to look at the quiz. Thanks for sending that.
Yeah, no problem. I think
Okay.
one of those, the third problem is wrong.
Okay. What did he make a mistake on?
Because this is the quiz. Let's see. He said.
Yeah, that one isn't that bad. It's which one?
We actually did problem 3 today in class. I'm pretty sure. Yeah.
Okay. I'll have to show that then. There's this thing right here is important for the local minima. But I want to ask you guys how does your professor do it? Because I mean it's pretty simple. But you already know how to do that.
Yeah. We just made a signed table.
Okay. Okay.
And then for part A of the third problem.
Okay.
We did work that out in class, and that includes quotient, product, and chain rule all in one.
Yeah, that was a fun one.
Yeah. So yeah, I have the work here, and we
Okay.
put it all out.
Did you understand the way he did it?
Yeah.
All the steps.
Yeah.
Okay.
I think I got most of it.
Okay. And let's see. What about this guy?
That was the one I was extremely lost on. Yeah.
Did he show you or explain how you do that? I had to look back at something. Here, let me just.
He was going to today in class, and then
Okay.
he didn't have time to do that one. So.
Okay. I guess for the way I've seen this problem done, I would just create a table. You could graph it, but that's just for visual purposes. But here.
Oh dang.
Did he give you guys an answer for it, or you have to figure it out?
Yeah, no, he didn't. I think we're probably gonna go over it tomorrow in class, but.
Okay, so this is good then. So how I would do this problem is how it's technically just a function. He gives you guys a function, but it's in turn it's not it's an arbitrary function. He gives you guys points for it, right?
Yeah.
And so like what I would do is create a table like this and like just fill in what you know, and then eventually, because then there's like so many things being mapped to whatever.
Mm-hmm.
So like, you have this like f of x, and then like you have this like, and it's being mapped into this h of x, and then what you really want is the the first derivative of h, right? For the first one,
Yeah.
for a. So like you just map it like and fill in what you know. So that's what I did. I did x here, f of x. Then you did create a table an f prime, and
I'm
put h.
a little confused on how 2 and 4, which
Okay.
the first thing you have is just x,
Okay.
and then the second one is f of x. Because on the quiz it looks like they're the exact same, like layout, you know.
For which one?
So it says f of 2 equals 4,
Yeah.
and then f of 4 equals -2. So how do you differentiate x from f of x, like in your top column?
Oh, because of this x part. Like you have to plug this in where the x is. You know what I mean? Like so, like this f2. This is f2.
Yeah.
This is the reason why you have x on the side, because then you can refer back to like what is x for all of these guys. Does it make sense? Like for this guy, if you plug in 2, then it's 4. If you plug in, you're already given these ones. If you plug in
Okay.
2 here, you're gonna get 6, right?
Mm-hmm.
From these two, 4 and
Mm-hmm.
6. Yeah.
Oh, okay. I see now.
Yeah. I think the bottom part here doesn't really matter for
Yeah.
this first part. There's part A. It doesn't matter.
Okay.
But the next one is like a little tricky. So okay. So then this is what you know. These are the givens. But then now let's look at what we don't know. So let's look at like h of x, right?
Mm-hmm.
So you have h of x. It tells you it's f of x squared. That's what it says.
Yep.
Yeah. So what I would do is like just fill this in. So you have 4 f of x, right, from this
Yeah.
guy, and then you just do the operation. So you have 16, right?
Yeah.
4 squared. Yeah. So at least one part is down, but then the h prime is the last thing that you need to figure out for this one. So what is h prime? So you have to apply the chain rule on this.
Okay. This is for part B now.
For part A, still part A.
Oh, okay. Part A.
So like okay, so part A is h, and so for h of x you have f of x squared, right?
Yeah.
And we got that as 16. You just put in 4 for f of x, which is given, and then you square it, you get 16.
Mm-hmm.
But then the question is asking you to find h prime where x equals 2, right?
Yeah.
But then we don't have h prime. We don't have an equation for h prime of x.
Mm-hmm.
So I guess that's the first thing we need to find. So we do know that h of x from here. We have that equation already. It's just f of x squared, right?
Yeah.
So you guys have learned like the chain rule and all of that, but this is a little like weird because then it's a function and there's a point there. But technically, what's it to you to just apply the the rules to this one, right? You could still do that. You could still apply the rules to this one, right?
Mm-hmm.
So it would be just do the power rule and then do the chain rule.
How did you?
Okay.
A little bit confused on how you went from f of x squared to
Okay.
to 2f of x. Like, where do you get the f prime of x from?
Okay. So let me.
So you did
So
the
like
power rule, right?
I did the power rule first, yeah. So like the 2 here,
Mm-hmm.
you know that one, yeah. That's like f of x, but then you have 1 now here, right?
Yeah.
But you can't just do a prime here because this is a term. It has to be f prime of x.
Okay.
If this was just like f of x and there's no power,
Mm-hmm.
you can technically just do this one.
Okay.
But
I
but then but you have that power, so it has to be that power, and then you put it on the side, which is the chain rule. It's pretty much what it is. Every time you have that power, that's more than one. You can't just apply it to this guy.
got it. Okay.
Yeah, this one does like a little, like I said, like looking at this equation, it's like even the next one looks a little menacing. So I'll show you that one
Okay.
after.
Okay.
But
So
okay,
then once you're here, you just plug values in, right?
yeah, and you already have them.
Yeah.
You already have them. Like these, this is pretty. This is the first. You don't even have to. Let me
4
see.
and 6. Yeah.
You don't even need this guy, honestly.
Mhm.
You could have just he just gave you guys like what this is so that you can figure this out.
Yeah.
Yeah. So that's what I got, and then you plug in that, and then I got 48.
Cool. All right.
That one. What do you think of that one? Like, does it seem like it's like awkward to do? It was a little bit because then you're
Yeah.
not given the function. It's a point.
Mhm. It was a little bit awkward. Yeah.
Yeah. And I thought at first I was like, oh, if you put in the value, does that mean it's 0?
Mhm.
Okay. Let's look at the next one because this
Yeah,
one
that's
this one's a tough one. Like I was looking at this. Yeah, it's right here. It's,
mhm.
and I think you have to use like both of them now.
Okay.
Here, so you still have x, right?
Mhm.
And f of x, and then f prime. Those are given. But this one, these you have to figure out that you actually have to get them, but it's not as obvious until like you take a look at this guy. So I guess I'll explain this guy first. So you know how like you have the k of x, it's a fx squared, right?
Mhm.
And then f, and then the x is actually squared, and that's what you put in the function.
Yeah, I see that.
Okay. So, but what does that mean? Like at first, I was like, oh, what do you do? And that's the reason why I was like thinking like that's why you need this. And the reason for that is somewhere here. So I tried to figure out what this meant. So I just plugged in what I knew, what x what is.
Mhm.
So that's 2 for this line, right?
Mhm.
And then I took this, square root of that, and then what do you get? You get f of 4.
Yeah, okay. So it's just f of 4.
Yeah, which is this guy. So then
Mhm.
it makes sense why you need the second line.
Okay. I see now, yeah.
And then same with this guy, which is this.
Yep.
Okay, so those two make sense. The bottom ones, I tried to see if you can even figure it out, because like for A you could, but this one you cannot. I don't think it's given to you.
Yeah.
Okay, so these are given. So knowing this, and then now you can plug them in here. So I got like negative 32 for k of x, just following the equation. And then this is where it's like confusing.
Yeah.
So for k prime, for all of this, like just the general, I guess, way of looking at it is, what can you like how can you manipulate the equation, and then what are you given the points, and then like just applying your the calculus rules and see what equation you get.
Mhm.
So the confusing one is like the second term. Right? Let's go with this one first. So what did I apply here?
Um Product rule.
Yeah. So yeah, so this is me applying the product rule, and then I think this one is from the top. This
It
f
looks
of x.
like
Yeah.
chain rule.
Yeah. So again, like if you have this 2 like
Mhm.
squared, you leave this guy here.
Yeah.
And then so and then that one is just gets multiplied. But then what about this guy? So this one's a constant. What about this guy?
That is also chain rule.
Yeah. So this
'Cause
is
it
like
can-
kind of like an internal chain rule.
Yeah.
Because then you apply it to the big one, and then you apply it inside the smaller one, and then but this is still 2, so you just apply the power rule there.
Okay. Yeah, I see that.
Yeah, and then you have the x value. Like what is it to if you just multiply it? Like I said, it's like it's functions and then a bunch of like no. So this one was a little trippy. It's like, oh, can you just do this? But you have the x, right?
Mm-hmm.
So I guess you can, since like from the equation, that's what you got. You just have to plug it in now.
Mm-hmm.
And yeah, you just plug in everything, and I got this guy. It's weird, right? Like this one's a little weird.
Yeah.
I don't know.
All right. I think I get that better now.
Okay. Yeah, please do confirm if that's how you do it tomorrow.
Okay, yeah, I will, yeah.
My first like look at it, like look in doing this, like it makes sense doing it this way. But yeah, we'll see if it's
Yeah, I mean
actually...
that's a lot of I feel like that's kind of a lot of work to do because we only had 20 minutes.
Yeah.
Like,
But he never
geez.
was there ever like a problem similar to that one in any lecture?
No, never.
Why
Nothing
does
like
he?
it.
That's kind of brutal for you guys because like you can't just like show a problem,
Mm-hmm.
where it's like
And
totally new.
most of the other stuff he even has taught us, but it's like the examples he shows us in class are like 2 times easier than the ones on the quiz. So
Man, he's really and then especially like these I think number one, this one we talked about this one, I think.
yeah, I think we did.
Yeah, so number one is the giving you guys that is like brutal just for an exam standpoint.
Mm-hmm.
Okay, so you got number 1 and 2, and then 3 is set to go, right?
We did that one today in class actually.
Okay, did you want to go over it a little bit or?
Honestly, I feel like
It's
just
good enough.
doing like more problems with all 3 of the chain rule, product rule, and quotient rule.
This guy. Okay.
Yeah, that would probably help out.
Yeah. The were you able to open the worksheet by chance? Like
Yeah, I did.
Okay,
I
you
opened a
did.
couple, and I did a few practice problems, a few worksheets, different worksheets.
The ones like the way I would probably attack, because like this professor is brutal as heck.
Mm-hmm.
And then like doing like minimal stuff, like the basic stuff may not be it is helpful obviously to reinforce like making all the rules natural like in the end.
Mm-hmm.
But like doing something like this, it seems like it would be better if you maybe like do this problem but with different numbers, change some of the coefficients.
Yeah, that's what I was thinking.
Yeah. And I think like that would be very helpful in the end. And then you probably have, do you guys, what's your guys' system for figuring out like the minima and the maxima?
They're just tables. So like the variation table, he calls it.
Oh yeah. Is that just like when you find the values at the where it's 0 at f prime,
Yeah.
and then plug that back in the f where it's like 0, something like that?
I think I'll just show you my chart. Let's get the light on.
Okay. Yeah, because that one actually is very helpful. It's like one of the first steps where you apply like derivatives.
That's our chart right there, the variation chart.
Let me see. Let me enlarge this thing. Okay. Oh, I see it now. Plus or minus. Okay, I got 6. That's good. Oh, he does this. Okay. 6. Why does he do what does CCL stand for?
CCL means conclusion.
Okay.
Yeah, so then it's just like basically writing out everything the graph says or the table says,
Okay. Oh, okay. As long as this one makes super, the way I usually do it is just, I just find like the points, the critical points, and then after that, then I would just like the local minima and then the local maxima. Usually, if there's an endpoint, you have to test those, but this one doesn't have endpoints. It's like a
Yeah.
infinity. But so you would just look at like where the first derivative is 0, and then where it's undefined,
Mhm.
and then you just assess the values for the function once you plug that back in.
Yep.
Pretty simple, yeah. It's a systematic thing, but it's like one of the first ways of like applying a derivative.
I mean, I feel like in this problem, definitely the most trouble I would have is getting the second derivative, like
Oh, yeah,
all that algebra.
yeah, like doing a second derivative is just another, and that's like a concave up, concave down. That's another one.
I just
When
mean
you
like the work though. Like, did you work it out to the second derivative?
for this guy,
Yeah, like look at the bottom. It's
let's
pretty
see.
brutal.
Yeah. Yeah, and every time you have the quotient rule, and when you do, like when you let me see, let me look at the actual. So this is the first derivative, right?
Yeah. This is the second derivative in our example he gave us, but
Yeah. So this one, and then you take this guy. Yeah, like it's just practice. Just keep on doing a lot of these guys. How is it with the simplification?
yeah, that's what I mean, he did it for us today, but I feel like I'd still have trouble doing that.
Okay. So you pretty
He,
much like how did he give you guys like a preview of how similar the exam is to the quizzes
I mean, yeah,
in a way?
he's told us multiple times that the quizzes are basically like the exam.
Okay. Yeah, what I would do is besides just like because like you're gonna see them again. So just do them like 2 times or 3 times the quizzes. And then like maybe like the third time, it just like try to vary, try to make up different ways it could vary.
Okay.
And see if you can like solve those problems. Because he's not gonna give you the exact problem.
Yeah. Hmm.
But I feel like yeah, that's gonna be that shouldn't be that bad. Like, what do you think? Like, are you pretty confident with all the quizzes now that we talked about this?
Yeah. Um, yeah, I just think more practice would probably help, honestly.
Okay, for
Like
which one?
the one we did today was with all three rules was pretty tough. Like I don't know if I
Okay,
would
let's.
be able to do that very fast.
Yeah, not fast yet, but like if you do like a lot of them,
Hmm.
like here, maybe I can copy that one. Do you want to do one right now?
Yeah, honestly, probably.
Okay, so let's take a look at this guy, but let's change the 4 exponent to like a 5.
On the bottom.
This guy 3x plus 2, so there's a 4.
I can't see your screen right now.
Oh shoot! Hold up.
It's all good.
Okay,
Sweet.
you see it now?
Yeah.
Okay, let me just redraw that. So this guy change this 4 into a 5, and then like just change this 3 into like a 7. People
Okay.
really don't like 7s. Yeah, like I was teaching this algebra course to the 7th grader. Like he did everything correct except when there's a 7 every time.
What the?
Okay, so 2. Change this to a 2.
Okay.
And I think that's it. Let me just rewrite that one.
All right. Cool.
Oops.
All right. So taking the first derivative of this
Okay.
is a quotient rule, right?
Yeah, just do a quotient rule.
All right. 5.
And a bunch of like product and chain.
Yep.
There you go. Let me just check like what's the actual answer? If it's
Okay.
actually brutal or not.
Okay.
Let's see. So like I found out, that other program that you're talking about that does derivatives or like whatever calculus. Is it called Socratic? Well, it starts with S, right? You said.
Yeah, I think so.
That one, isn't it just like it's like a forum, isn't it? It's kind of like a forum, like people ask questions and then like it's not like super. There's another one called like derivative calculator .net.
Here, wait, let me ask you one. Spencer,
Yo,
Okay.
what's that one, like, remember that one calculator you showed me that had all the steps? Symbolab.
Oh, Symbol Lab. Yeah, I know that one too. Yeah.
for like more steps, I guess.
Yeah.
It gives you a lot of.
Yeah, that one looked like it had the most steps out of any of them, but.
And it's free.
Mm.
Yeah, that's good. Yeah, you could use that one. It's I think it does a lot of other things as well, like a lot of other calculus stuff.
All right.
Okay, so this one it's not that bad,
Okay.
but it is doable. So
Okay.
okay, let's look at it.
I'm working it out right now.
Okay, how long did it take you to work out the other one?
Which the one on the quiz?
Yeah, if you he showed it to you guys, right?
Yeah, so it took him 30 minutes to do the problem. So
Damn, 30. The whole problem though. Okay.
yeah,
That's fine.
yeah, he also gave us a couple in class today. He gave us an approximation, like
What is that?
approximation using linearization.
Oh, okay.
So that was part of the problem. He just like added another part, and then he said is it an underestimate or overestimate? So.
And did he say it was going to be on the exam?
Yeah, probably. It was on one of our quizzes too. Remember?
Oh, that.
Yeah.
Which one?
It was on
the third one.
Quiz 3. Yeah.
Okay.
Pretty sure.
Yeah. So this one is in. You could just separate this guy.
Let's see.
And like, a lot of this, like the way you would make it so that it's like faster for you is the way you arrange your things. Your terms.
Mhm.
So it's not like all gobbledygook. Like when you arrange these guys, try to like maybe you don't even have to simplify until when something cancels out. You know what I mean? And it's easier to read like this.
I just did it all out pretty quickly.
Okay, you got a term ready?
Yeah, I just want to make sure I have my first. Like, I haven't simplified yet, but I just want to.
Okay.
Make sure I have my.
All right. So for this, let's see. Okay.
I think it should be right.
Okay. Yeah, if you can do shortcuts, that'd be good.
I'm gonna try and start simplifying now too.
When you simplify something like this, usually like you take a look at like these terms with exponents and see if you can match one side of the one term and the other, and see if you
Yeah,
can
that's
factor
what.
it out.
Yeah, that's what we did today.
Yeah, that's what I did too. I mean, it's like a trick. Like it seems like at first it's not simplifying, but then it actually is when you group them.
Yeah. Mhm.
Yeah, it's like a
Exactly.
nifty one.
Yeah.
Okay, so this first part is pretty much that.
All right, and then it would be 35.
And so there's the next one. Okay, and then try to like not write as much. Like what I'm doing right now is like I was gonna write out every single step, but
Yeah.
I guess try
I
to
got.
bring down a few things and then rearrange them in the end.
Yeah, I got what you mean.
Because like one of those things is you think like, well, it's good for you to practice the steps in the beginning, but obviously
Yeah, when it's
the
quiz time or test time.
yeah. All right, so let's see. It seems like you could just this guy. You can just times it by this one. Oops. Okay. Yeah, so this one didn't turn out that bad.
Yeah.
It's actually pretty similar. So 4 plus 14 plus 35 minus 35x. Okay.
All right, I think I've just finished the first derivative part.
Okay. So what did you get?
7x plus 2q to the fourth
Okay.
times. We got the same stuff. Oh wait.
What did you get in the end? Did you get one? Did you get this in the bottom? This term in the bottom?
No.
What was your bottom? Like that's
I got 1 minus x cubed.
okay. Good. I got.
And
then what was the term up top?
7x plus 2 to the fourth times negative 21x plus 39.
Okay. Plus 39.
Yeah. So I got negative 21x just from.
Yeah. There you go.
Okay, cool.
And so so that's good.
Cool. So that's
think,
all right.
Yeah. That's pretty much the right answer. Yeah.
All right, sweet. That wasn't too bad. Yeah, I did that pretty quick.
Okay, now get the second derivative.
Yeah, this is gonna be.
Yeah, let's see. Let's see what the answer is first.
Do you think we should I like try and do a variation table really quick, just because that's
This one?
yeah. He kind of wants us. I
Okay,
feel
go
like
ahead.
he makes
Yeah.
us do it on every problem.
Oh, really?
Yeah, like he's
I mean, it's
crazy
good
about his
practice.
tables.
Yeah.
Okay,
Yeah, go ahead.
I'll just try and do it really quick. So x plus 2. Oh wait, that's actually, this might take a while because of the negative 21x plus 39 term.
Yeah.
It's okay. I'll do it on my own time.
Okay. Well, like, let me know if that one is pretty brutal. So
Okay.
yeah, let's just figure out the second one.
Cool.
The second derivative.
Cool.
Wolfram alpha. Okay. All right. Let me check what is actually the answer.
Okay.
Yeah, you could technically factor out a 3, but I don't think you need to do that one. It's not really simplifying. All right, let's see if it's not that bad.
Sheesh. It's gonna be rough still. Just
Okay,
looking
so
at it.
this form, I mean, there's just a quadratic. Yeah? I mean, all the terms. It seems like it's kind of similar, except for like that one term, like
Yeah, in the front.
yeah, it's just that guy. The numbers get kind of weird and big. Okay, let's see. Pretty sure he's gonna give you guys friendly numbers. Can you use a calculator for your? I mean, yeah, it doesn't matter since.
Yeah, he told us today that we weren't allowed to use a graphing calculator, but
Usually for if in-person exam, yeah.
yeah, but like exactly, we can just be on our graphing calculator.
Or Wolfram, yeah.
Yeah.
I mean, like you guys really got it easy.
Mm-hmm.
I mean, like that's what I'm saying. Like, I mean, in the end, as I say, like once you're past like all these like math parts, I mean, you're just gonna look back. It's like, oh, okay, it's easy, but then going through every step makes it like worthwhile.
Mm-hmm.
Now that you have to, now that you can skip it.
Mm-hmm.
Yeah. Okay, let's see what you have to do. I'm not gonna do this one, but let me know if you need help with any term.
Okay, so I'll just start doing the second derivative.
Yeah.
Okay, cool.
It's pretty much the same system. Just do the quotient rule.
Quotient
Power.
rule, product rule.
Yeah.
Okay.
It's just that combo. I mean, it seems like this is the most challenging. What he could do is give you guys like within this quotient rule product chain combo, like put like transcendental functions, like weird functions, like ln,
Mm-hmm. I mean, it's that would take us so long. Like we only have 50 minutes for the test.
And then like put in like a trig function that you have to like use to simplify.
Luckily he hasn't given us anything trig yet, so
Okay, that's good. I always at one point I always hated like, I mean, like it's before calculus, but you know how like when you have to simplify things with trig,
yeah,
because you have to like step back. It's like, how else can I manipulate this?
Mm-hmm.
So that's good. That's not that bad.
Okay. All right. So derivative of the top.
What I can do, let me see. I won't tell you this term, but I'll tell you the other terms.
All right. 4 times.
Oh yeah. Did you hear? Frog is gonna be doing Zoom soon. So did anyone reach out to you?
No, but my mom has been telling me a lot of
Okay.
stuff.
I mean, it's about time for them to do Zoom. I honestly don't like this Wiz IQ thing.
Oof. I just ended up with a mess.
Okay, what part?
Like
What did you do? What did you do first, and then then how did it get to that point?
Well, like I think everything's right. I did everything right, but it's still just a mess to simplify.
Okay, I mean that's not totally a mess.
Yeah, so it's not completely a mess, but let me just show you.
Okay.
Pretty rough.
Come on. I know I can enlarge this. Okay, enlarge. Oh, I see what you mean. Okay. Well, try to.
Oh, my bad. You can barely see it. Yeah.
And I can see it. I can see it.
Yeah.
Yeah, just try to like simplify it.
Yeah, let's see what we did in the other example.
The largest like power of that polynomial, like in the bracket, is like 2. So it's probably just the number. It's probably just the number.
All right.
Can you see like these terms popping out?
Yeah, I do have those. Oh,
Yeah.
oh, I see. Yeah, so it looks like I'm gonna have to do the same thing
Exactly, yeah.
that we did for the first one, which is just taking out common factors.
Yep. And then whatever is left is in the bracket.
Mm-hmm.
It's probably just the number. I'm seeing this number to be super high, like 1,000 something.
Oh God.
But at least the polynomial isn't too high. It's only to the second. So like, did he at least preview guys what he's gonna cover after this exam?
Not really, but I saw in our like lesson plan, it looks like we're going to integrals.
Oh, those are fun. Okay.
Yeah, I did them last year in math quite a bit.
Okay, so are you better in integrals than derivatives?
No, I was way better at derivatives.
Okay, well, I think yeah, everyone. It's just the rule. The rules are. I mean, it's switched, right? Obviously.
Yeah, it's the same, but backwards.
Backwards, yeah. Which makes it a little. What's it called? Integration by parts, and then partial fractions. Those are fun.
God.
So we'll probably talk about those because this other guy that's doing the calculus too. A lot of people, yeah, I know they always ask those questions, partial fractions, because it's like, when do you ever need that? Like I thought there was only integration by parts.
Mm-hmm.
But there's like other part too, like you sub all that, you know.
Mm-hmm.
Okay, I really want to see how you guys apply it though, because it seems like you know how are you guys applying it as in a business point of view?
Like just
Like
the math class so far, you mean?
yeah, like how is it applied? Like what problems do you see? Like I saw that cost
stuff in?
revenue one. Yeah.
Yeah, it's basically. I mean, I'm pretty sure it's nothing like actually more than a normal math class because we did that stuff in high school too. Just revenue and cost and like with functions with E like a per and stuff like that. I mean, that's all like
Okay. Should be interesting then. And not that hard.
Yeah. All right, so I'm expanding this and I mean, I can do it, but it's going to end up in pretty huge numbers, I think.
Okay. Then here. Did you at least get it to like a polynomial only? Like one polynomial?
No.
Okay.
I'm almost done, actually. I should probably just do this for practice.
But you see why what we're doing here? Like, I think this is good because then not only like we are applying the same step, right? Like it's pretty much the same thing.
Mm-hmm.
It's just like you're raising the difficulty
Mm-hmm.
for
Yeah,
yourself.
I mean, it's
which
just
sucks.
good practice. It's good practice. Because it's a different problem.
Yeah.
All right, so I don't know if I should finish this or not.
Are you almost done? I think we're almost done with this one.
I'm a little bit. Wait 1 sec. Let me see
Okay, I
how
guess
you do
just to speed it up, like you're gonna get this term. Like the number here is like 1284.
Holy crap.
That's the largest number. And then like this one's like 192x plus. And then I'll leave that other guy.
So I just have a quick simplification question really quick.
Okay, what is it?
I don't know if you can see, but
Let me see. Let me just switch to the Zoom.
yeah.
I don't know why I can't like hold up for a sec, right? Let me end this guy.
Okay.
Because like I know there's a way for me to still share and then look what you have, but let me see. Okay, I'm looking at the bottom one.
Yeah,
so
yeah, that's. So I'm
you
just
got
kind of
one
confused how to
minus-
simplify right now.
You got 1 minus 6 to the 6.
Yeah, but see how I pulled out a 1 minus x squared already for my factor. So I'm guessing that's gonna make the bottom go down to 1 minus x to the 4th.
Okay. It's a little blurry. So 1 minus x squared.
Sorry, yeah.
Okay, and then 128. Yeah, that's fine. It's just the numbers. The all the the simplification is there. You just have to arrange it.
Yeah, I'm kind of confused at the
How you
operation.
do that?
Yeah.
Okay. So after you pull out the 1 minus x squared, what do you have left?
In
Like-
the brackets.
Yeah, and then what after that? Then just minus the x. Minus like do the operation on the like terms and group them that way. That's usually how I do it.
I have, in
what's
the
your
brackets.
what's
I
your
have,
largest what's your largest polynomial? Is it x squared?
in the brackets.
Yeah.
I don't have any squared yet.
What do you have?
28 minus 21 times 7x plus 2 times 1 minus x.
Yeah, there you go. You're gonna get an x squared there somehow.
Okay, yeah, but I'm a little confused. Do I FOIL first or multiply the 21 into the 7x plus 2 first?
You FOIL first.
Okay, got it.
And after you FOIL, then you have this whole thing in one bracket, right? One parentheses.
Mm-hmm.
And then anything outside that you times to it. But you always need the FOIL first.
Okay, got it.
Okay, let me look at this.
I might be doing something wrong
Okay.
because
What happened?
my it looks like my cubed term and my just x term are gonna be larger than the third term.
Cube term and it's larger than. Okay. Let me see.
I mean, I'm just doing this algebra wrong. I already know. I wish I could just like.
See, so okay. So you're not able to get an x squared term, is what you're saying. That's not the lowest.
No, it is. I have an x squared term.
Okay.
But I'm telling you, it's gonna end up bigger than the third term. You know what I mean?
Bigger than the third term, because like.
Than 1284. Yeah.
This is technically the. Okay.
Oh. Yeah.
Did you get? It's not 1284. 1284 is the one without the x. Did you get 294 x squared?
Wait. Let me actually. God, I just don't know whether to do this subtraction. I'm like spacing out.
Is there a negative there? Here for this one, I'll try write out like, up to this point where before you simplify.
All right.
Let me see what we would do. Like after the calculus.
Yeah, I can read it out to you if you want.
Okay, let me just try to see if you have this same one.
Okay.
So I have what I would do is like, let me see, is minus. You got this guy coming, and then you have this. See if we can create the top one with this guy. One minus x. And 28. 1 minus x cubed. Okay. For this one, well, since this part right here, did you get like somewhat similar things here?
Yeah, mine are just in a completely different order. And also
Okay.
I have all of the things on the top over 1 minus x to the 6.
1 minus, oh yeah, so you had 1 minus x to the 6.
Because of quotient rule.
That's what they did, and okay, that one plus that one. You should use this one. You should be able to get an x to the 4th.
Yeah, but by the end, if I was able to factor what's in the
Yeah, it cancels
brackets.
out from the top, right?
Mm-hmm.
After canceling it, what was your numerator looking like? Like it's the numerator that we need to manipulate. So it's just like 28. Okay.
Yeah, Yeah, I have 28 minus 21 parentheses 7x plus 2 times 1 minus x.
Okay, sounds about right. So now you just have to put them together.
Mhm.
Do you have this term? You have this term?
Yes, I do. But I also have it multiplied by 1 minus x on the top.
So it's going to be, you have this top part times by 1 minus x, 1 over x, or 1 minus x?
Parentheses 1 minus x, yeah.
1 minus x. I have that, yeah, of course, because you need to combine them. Yeah, you need to combine them with this other guy.
Yeah,
So
so in mine, I don't know if I did this wrong,
okay.
but like, here, let me try and show you this. Sorry, so
Stop
right
broadcast. Let me see what you have. Okay, I see it now. Can I see it again?
Yeah, right here, the first part, right here,
Okay.
that's 28.
Okay.
You
That
see
sounds
where
right. Yeah.
you see where I moved it down to the second step I had to put it in the brackets, right? Because that's not a like term.
28 minus 21.
Yeah,
Oh,
that's where I'm
I see.
confused.
I see what you're saying. What in the world? Let me see. The top looks right, but then like, so you have that cube term, right? 28 times 7x plus 2 to the cube, right?
Mm-hmm.
And then the minus 21, 7x plus 2 to the fourth. You could probably take out the 7x minus 2, make that cube, just to like take out, because you're gonna end up having a cube in the end up top. It's gonna be like 2 plus 7x cubed, not to the fourth.
Yeah, I have that.
And then like, can I say it again?
Yeah.
So and then when you do the 1 minus x cubed should cancel. Yeah, it should cancel the 1 minus x to the 6, which is good.
Mm-hmm.
Right? That's good. And then
Just the part in the brackets is what I can't seem to get, or like
the bracketed term, the 28.
Yeah, 28 minus 21,
21.
that part. I feel like I messed up.
No, you didn't really. So you have like, you should distribute the 21 to the 7x minus 2 or plus
Okay.
2.
Okay.
You know why you have to do that? Because you're gonna simplify that somehow. Like, it's gonna minus somewhere, some place.
Okay. So then I think that would just solve things right there.
Also, you see it?
Yes.
Perfect.
So if I multiplied the 21 to the 7x plus, oh wait. Okay, yeah, we can still do that. 21 times 7.
The trick with those polynomials and a bunch of these things being raised is like, after you do the calculus, try to group, because you know what it's gonna be. Like the ones raised to a power. Try to see if they're like together, you know, like you can make them put together, and anything that's not raised to a power, you can multiply out the constant and make a polynomial out of that, and then cancel a few things. That's like kind of like the process.
Okay.
And then I guess to keep in mind, don't get bogged down. Know that you have to FOIL first, and after,
Yeah.
you know, once you FOIL, you simplify. Like you can't you can't distribute the constant until you FOIL. You shouldn't do that. You know why you shouldn't do that? You could do that, but like if you do that, it's gonna make the math harder.
Yeah. Exactly.
Yeah. Like if you FOIL, and then like, yeah, so I guess my suggestion is just keep on doing another one like this.
Yep.
I'm pretty sure you got this one already. It's not that bad.
Yeah.
And then I was wondering, for when your professor, he's probably gonna talk about a different like different things for after this exam. Can you send that to me?
Yeah,
Maybe,
I will.
because like so that for like the next session, I'll try to see if we can do like cover a lot of ground every week, so that like I want to give you more practice. Like this one, I know it's a little bit short. I wanna give you more practice. Like,
Yeah.
but then there's like so many things that we did.
Hmm.
But if we did like we focus on one chapter, one homework, one quiz every week. I
Yeah.
think it's more reinforceable.
Yeah, definitely.
Okay, let's do that, and then let me see. If you can send me that, and then I'll just text you about like when do you want to do when do you want to cover that homework, the next homework?
I don't know yet.
Because today is like one, and I think we can. Someone told me we can do one more this week.
Okay. Oh, this week?
Yeah, because supposedly like tomorrow, but then I think you have it. You're super confident about this one. I know you're gonna
Yeah.
get an A. Let me know if you get an A.
Yeah.
I'm pretty sure you're gonna get an A. It's not that bad, man.
All right, cool.
Okay, and then just let me know, and then I'll kind of arrange with you the next session. If this, when did we do it last time? Do you remember? Was it a weekend or was it a weekday?
I think it was a weekend.
It was a weekend. Okay.
Saturday.
Okay, sorry. Okay, does that work for you more? Like if we do that every week? Or
Probably
weekday?
not. Yeah, weekday if possible.
Okay.
But the thing is, I don't know when I'm gonna be getting the new content,
Okay.
because
I'm
our
just
midterm
looking.
is Wednesday.
Is it Wednesday? Okay, so Wednesday. Okay. Because I'm just looking at my weekly thing just to like keep it consistent. So my Thursdays and Fridays, do those work for you? Like to make it consistent, like every week?
Yeah. Mhm.
Which day works better?
Thursday, if you have well, it depends what times probably.
Okay, good thing we have the same time. So Thursday, I have only one person, so any time for me after like 5 is good.
Cool. Do you think you could do at 5 or like 5:30 maybe even?
5:30 sounds good. Okay. Well, yeah, we'll figure out the time later on. But Thursday is like gravy for all of us, right?
Yeah, that's good.
Okay. Cool. All right, man. Have a good one.
Cool. Sweet. Thank you, Paul.
Yep.